Welcome to week 4. This week we are going to be working on simplifying rational expressions. Okay, so a rational expression is a quotient of two polynomial expressions. Okay, so we're going to have pretty much a fraction with two polynomials, one up top, one on the bottom, and we will simplify them by factoring everything first. Okay, so that's why factoring was really important. We are going to be doing a lot of factoring with rational expressions, and we will be working on this for the next 3 weeks. And so factoring is going to be our primary thing that we're doing in simplifying rationals. Okay, then we're going to simplify the monomials using exponent rules and eliminate any common binomial factors. So let's take a look at number 1 here. Number 1 says 20x to the 6th all over 14x squared. So we're going to reduce our monomials here. So 20 and 14 are both divisible by 2. So I'm going to reduce 20 over 14 to be 10 over 7. And then I am going to reduce the x's. Okay, remember the exponent rules. When you're dividing, you subtract the exponents. So x to the 6th over x squared. Okay, we're going to do 6 minus 2, which will give us x to the 4th. So it's 10x to the 4th all over 7. That would be our answer. All right, so looking at number 2, we have 6x minus 36 all over, or that's not x, it's k, 6k minus 36 all over k minus 6. So the first thing we're going to do is factor, if we can. In this case, we can factor out a GCF from the top. Okay, we are going to factor out a GCF, which is going to be 6. So if we factor out 6 from the numerator, we're left with k minus 6. And there's nothing to factor in the denominator, so we'll just leave the denominator as k minus 6. Notice that we have a k minus 6 up top and a k minus 6 on the bottom. Now, very important here, anything held together with a plus or minus sign, you need to keep together. Okay, don't try and break those things up. So this binomial factor of k minus 6 will reduce with this binomial factor k minus 6. Okay, they have to match the binomial itself. Okay, so since those match, they will become 1, and your answer is 6. Okay, we will be talking about points of discontinuity, but not yet. And I just want to quickly mention it here. Points of discontinuity is where the function will not exist. Okay, if you were to graph this, you would have two pieces. It would be a hyperbola. Notice if we plugged in 6 for our answer, okay, if we plugged in 6 here, we'd get 6 minus 6, which is 0. That would make that undefined. Okay, and that would just be a point of discontinuity. All right, so number 3, we have y plus 8 in the numerator and y squared plus 2y minus 48 in the denominator. Now notice the denominator there is a trinomial. So to factor this, we want to find what multiplies to give us negative 48 and what adds to give us 2. Okay, so this is where factoring becomes important. So it multiplies to give us negative 48 and adds to give us 2. That's positive 8 and negative 6. So in the numerator, we have y plus 8. Okay, there was nothing to factor there, but then in the denominator, we have y plus 8, and y minus 6. Okay, a hint here, when simplifying rational expressions, you'll almost always have something in the numerator that matches with the denominator. So that will hopefully help a little bit with factoring. So we should see that we should have had a factor to match with y minus 8, or I'm sorry, y plus 8, which we did. Okay, so since we have a y plus 8 in the numerator and a y plus 8 in the denominator, since they match, we will eliminate those. Okay, when you cross it off, you're not left with 0. Okay, you're not left with 0, you're left with 1. Okay, because remember what we're doing here, we're reducing anything over itself is equal to 1. So it becomes 1 all over y minus 6. Okay, looking at number 4, we're going to factor two things. Okay, we're actually going to factor this numerator twice. We want to get rid of our a value, what's in front of our quadratic term, if we can, because that will keep us from having to factor by grouping. So the first thing I'm going to do here is I'm going to factor out a GCF from both the top and the bottom. Okay, so my numerator is going to become 2 times r squared minus r minus 20. And the denominator, we can factor out an r there, or I'm sorry, an 8, which leaves me with r plus 4. Okay, so we have to factor the numerator again, and here's a little hint. Since we have an r plus 4 on the bottom, and that's really our only binomial there, we'll be looking for an r plus 4 to be on top as well. So now we're going to factor this trinomial, and it's what multiplies to give us negative 20 and adds to give us negative 1. Okay, what multiplies to give us negative 20 and adds to give us negative 1. That would be negative 5 and positive 4. So that numerator is going to factor into, don't forget the 2. 2 stays out front. And then we will factor this into r minus 5 and r plus 4. And in the denominator, we still have our 8 times r plus 4. Okay, so we want to reduce anything that we can. Notice we have a 2 that will reduce with this 8. Okay, and we also have 2 matching binomials here, r plus 4 and r plus 4, that will reduce. So since I have an r plus 4 and an r plus 4, those will go away. My 2 and 8 will reduce. So I'm just left with r minus 5 up top, because the 2 will become a 1. And this 8 divided by 2 will be 4. So my answer is r minus 5 all over 4. All right, number 5, something a little tricky happens, so you got to be careful here. When we factor this numerator, notice that this is the difference of two perfect squares. Hopefully these are becoming easier to recognize. Okay, that's dots, the difference of two perfect squares. So we take the square root of p, the square root of 49, and it's plus minus. So the numerator will be p plus 7, p minus 7. And our denominator, now this is where we have to be careful. Okay, our denominator is 7 minus p. This is not the same as p minus 7. Okay, 7 minus p, I'll write it here, 7 minus p does not equal p minus 7. Subtraction is not commutative. But what we can do is we can factor out a -1 from there. And if we factor out a -1, then we can reverse the order. So if we factor out a -1, okay, if we factor out a -1, that will become p minus 7. Okay, so it says, watch out here, a minus b over b minus a. That's not equal to 1, it's equal to -1. And we can't forget that negative when reducing. So now I have a p minus 7 that matches with a p minus 7, so those will reduce, leaving me with p plus 7 all over -1. Or you may see it written as -1 times p plus 7. All right, we have just a few minutes here. The one I want to go over next, let's see, we can do number 6 next. Okay, for both of these, we're going to factor out a GCF. Both the numerator and the denominator, we will factor out a GCF. Okay, that numerator, I'm going to factor out a 3a. And that will leave me with 4a squared minus 1. In the denominator, I'm going to factor out a 6a squared. And that will leave me with 2a plus 1. Okay, now looking at this, nothing reduces except the 3a and the 6a. Okay, but notice that 4a minus squared is dots. That's the difference of two perfect squares. So I'm going to factor one more time in that numerator. I have 3a up top still, and I take the square root of 4a squared in 1, and it becomes 2a plus 1, 2a minus 1. And then the denominator is still 6a squared times 2a plus 1. Okay, we have 2a plus 1 and 2a plus 1. Those will cancel. And then I'm going to reduce 3a and 6a squared. Okay, the 3a will turn to 1, and the 6a squared, okay, will reduce to 2a. So my final answer will be 2a minus 1 all over 2a. Now this is what you guys will have to watch out for, because I'm sure that this will come up. Okay, 2a minus 1 and 2a. What I will see a lot of times happen is you guys will say, oh look, 2a and 2a, cross that out. Okay, no, you cannot cross out 2a and 2a and be left with -1. This negative connects this 2a to this 1, and you cannot separate them. Okay, you cannot cross off this 2a with this 2a, because this 2a is connected to this -1 with the subtraction. Okay, they are bounded together. Do not try and separate them. All right, it looks like that is all we have time for. This is the end of the 15-minute video. If you have a lot of questions or you're struggling on the assignment, please come to the live meeting or text me or call me. I will be available.